Hi, my name is Jim Fitzpatrick with Agilent Technologies. I'm going to take a few moments of your time today to introduce you to the Cary 630 infrared spectrometer and some of our unique accessories. The first thing I'd like to do is point out that in spite of the size of the spectrometer, this is not a toy. This is a fully functional, full spectral range, two-wave number resolution spectrometer with interchangeable front ends. So in spite of the size of the system, this is a fully functional lab spectrometer. The accessory that you see on the spectrometer at the moment is our transmission module. And within that module is a traditional transmission device. And this device is a mainstay of infrared spectroscopy, but is also the bane of the infrared spectroscopist's existence. This accessory requires a spacer, it requires salt plate windows, it requires samples to be diluted before they can be pushed through the accessory. They require extensive cleaning with solvents. And this is, in fact, antiquated technology. I'm going to show you a technology today that makes this obsolete. Let me swap accessories. To do so, I'm simply going to pull this lever and completely remove this sample compartment. You'll notice that the sample compartment has an RFID chip, and that allows the spectrometer to recognize the accessory that's in place and then pull the correct parameters. The accessory that I'm excited to show you is actually a DialPath. And we call it a DialPath because we can dial in the path length without having to disassemble the cell. So this has two salt plate windows, one here and then one on the end of any one of these 3 points. And what this allows us to do is to choose between path lengths simply by rotating the second crystal into position. So in this case, this is set to 50 microns. There's a cheat sheet, if you will, on top of the accessory that tells us that position 1 is 50 microns. Position 2, in this instance, is 100 microns, and position 3, in this instance, is 200 microns. Now these can be set for the user depending on the application that they choose. So what I'd like to do today is go ahead and run a sample for you using this accessory. I'm going to collect the background. This is our software screen. You'll notice that the system recognizes that I have a dial path in position. I'm going to choose a method that will set the parameters for this accessory. And in this case, I'm going with a method called DialPath dioctyl phthalate. This is a biodiesel simulant. I use a simulant because I don't want the sample to evaporate, and this is a very stable simulant for a biodiesel in diesel application. Biodiesel in diesel is usually from 1 to 5%, so this is a perfect application for a sensitive accessory that may need to change path lengths depending on how low I wish to go. Notice that the appropriate accessory is selected and indicated on the screen. First thing I'll do is I'll take a background. This method already sets the background for me. So I'm prompted to clean the sensor surface. I'll use some acetone and a Q-tip. Rotate this to a position that allows me to clean. And I actually, out of good habit, I clean all 3 sensor surfaces at the same time. And you'll see why in a moment. There are times when I will roll one of these heads through the liquid to get to another position, and I'll want to make sure that I'm not contaminating the sample. So now I'm in position at 50 microns. I'll hit the next button and the system will check for cleanliness and now collect the background. While it's collecting the background, let me just point out that our software is methods driven. And that means that the user can walk up to the system, choose the method, the path length will be set, the spectral range will be set, the resolution will be set, all of the common parameters will be set for the user without the user having to go in and choose multiple parameters from the drop-down menu. So in this instance, we're just finishing the background and we're now ready to place our sample. So this is the dioctyl phthalate that I mentioned to you earlier. We're going to choose several drops and place it on the system. And what I'll do is I'll rotate out of the way, and this gives me free access to the lower window. A couple of drops of liquid are all that's needed. 1, 2. And now I'll rotate back into position. Hit the next button, and you'll see a preview of the screen. Again, this is a key feature of our software packet. Notice that we haven't had to make any choices other than to hit the next button. We're able to step through the software without any specific training. It's as if we were moving from one web page to another. We can hit the back button or the next button without having to make parameter choices. In this screen, this is a preview screen. What this allows us to do is to make sure that we have enough sample present. It also is the place that we would name the sample. So I'm going to name this as dioctyl phthalate. I'm also going to zoom in. This is a very cool feature. What I'd like you to see in this instance, this is a very small peak. And again, remember, we're only at 50 microns. But if I rotate this now into position number 2, just to show you, you'll see that this peak will actually double in intensity. There's twice as much sample now in the path of the infrared beam. And if I rotate to one more position, we're moving now to 200 microns, you'll see that that peak has doubled in intensity again. So while we wouldn't do this as part of an application, it's just a neat opportunity for me to show you that we can move from 50 microns to 100 microns to 200 very quickly and very easily. However, to do the analysis, I'm going to rotate back to position 1. And again, to complete the analysis, I simply hit the next button, and then the analysis will be performed. A unique feature of our software is that we give results, and those results are set by the customer. Do you want a quantitative result? Do you want a yes/no, a pass/fail, or do you just want to collect spectra? So we can set the output, or the customer can set the output to whatever format they desire. So it can be a simple pass/fail, it can be a quantitative result, and if we chose to, this is green, which means that the threshold is set to pass. At 2%, it would be red. At 1%, it would be also green, and then there's a parameter that would be yellow as we approach that critical cutoff point. So when we are done, you'll notice the software will loop back. Now it prompts us, we should clean the sensor surface. So that's what I'm about to do. I'm going to simply take some acetone, rotate out of position, and clean. What's unique about this accessory, I showed you one path length, but there are many instances where your first sample is at a path length of 50 microns. However, a different type of sample comes in, a different method needs to be run. You would then switch to a 200 microns, and without any path length changing, without spacers, without windows that can be cracked or broken, you are changing path length simply by rotating as you see me do here. This is very unique. This is patented technology by Agilent Technologies, and it will do for liquids analysis what the Diamond ATR has done for solids analysis. Speaking of the Diamond ATR, let's show you how that would work on our system. So I'm going to now replace accessories. Notice the ease with which we can swap accessories. We're now going to move to a Diamond ATR and show you again how this system very quickly and easily runs solids, liquids, powders, pastes, and gels. The system will prompt me at this point, it's warning me that this accessory is not compatible with the previous method. And that makes sense because the previous method was a liquids analysis using a DialPath. So what I will do is accept that warning and choose the appropriate method. So we'll go to our method screen, and I'm now going to choose a EVA quantitative method. This method is quantifying vinyl acetate in an EVA, ethyl vinyl acetate polymer. Traditionally, it's been a difficult analysis because we're working with a hard polymer bead and we're trying to analyze that simply and quickly. I'm going to take a moment to swap out the sampling head. This sampling head on the diamond ATR is appropriate for powders, but I'm going to choose one that is appropriate for beads. Notice it's stored on the side for easy access, and I'm going to screw this into position, and then we will be ready to analyze the bead. So just rotate this into position and we are ready. What's cool about this little tip is that it's concave, so it actually cups the bead and forces the bead to make contact with the diamond ATR. The software is set up as a loop, so as we run a sample, it takes us through to the analysis point, gives us our result, and then allows us to start back over with another sample. So we're going to hit the start button. It will prompt us to clean the crystal. So from the previous use, there may be some residue. If we don't do a good job cleaning, the system, if we have that feature turned on, will catch the fact that we have not removed the previous sample. I'll hit the next button. And the system will now check for crystal cleanliness if that's a feature we have turned on. In this instance, it is not a feature we have turned on, but it will catch previous sample contamination if that is a feature we have turned on. Now I'm going to run an EVA polymer bead, and this cupped pressure device will become very useful here. Otherwise, the bead will bounce or move around. So I'm moving this crystal, this little polymer bead onto the sensor, and I like to use the preview screen, and what that allows me to do is to determine if the sample is in proper position and am I applying enough pressure to get a good spectrum. So in this instance, I'm going to name this as unknown sample, unknown EVA, and as I apply pressure, you'll actually see the spectrum growing in here. It's a very cool feature of the software. So this is a quality spectrum. I'm satisfied with this. The quality of this spectrum, the signal to noise looks excellent. The bands of interest to me are prominent. So I'm going to initiate a sample collect. This method is a quantitative method. It is set up to quantify the amount of vinyl acetate in an ethyl vinyl acetate polymer. And so we would expect a percentage answer to be returned to us. And in this case, we received a 25% vinyl acetate concentration in the polymer bead. We hit the done button and it loops back to the clean the crystal screen. So at this point, we're ready to run another sample. To do so, I will clean the crystal, remove the previous sample, wipe using acetone or a similar solvent, and then move into my next sample. The diamond ATR is also ideal for liquids. To use a diamond ATR, simply place one drop of liquid on the diamond. No pressure is applied using the pressure device as the liquid makes intimate contact, and we click the next button to perform the analysis. I use the preview screen again to make sure that the liquid is on the diamond, make sure that the spectrum is of high quality, and then proceed with the analysis. What I'd like to run next is a simple powder. Again, a difficult sample to run without the right accessory. Diamond ATR is the right accessory for this. To do so, I'm going to remove the concave tip. Concave tip is not the right tip for a powder, and I'm going to insert a flat tip which will compress the powder against the diamond. For storage, just so I won't lose it, I put the concave tip in the side of the accessory. And again, we're back to a software loop. Hit the next button after cleaning the crystal. It will collect a new background for this analysis. So we're ready to place a sample on the diamond ATR. I move to the preview mode, and this is an aspirin. Simply put enough powder on there to cover the diamond, and then lower the pressure device by turning. Now you will reach a slip knob, and that tells us we have enough pressure. And the only thing I would like to point out in the window is this is a, again, 1 second update. So this is a 1 scan update, and notice the quality of the spectrum. This is very high signal to noise. This is full spectral range. This is high resolution. So this is a very high performance but small package infrared spectrometer.